Hi everybody. Today we're going to talk a little bit about arcs and chords and some of the specific relationships they have with each other. So let's jump right into it. The first thing we need to know is that there's a relationship between chords and the corresponding arcs. So for example here, let's just say BD was congruent to LM. So let's say BD, and these are obviously both chords because their endpoints are both located on the circle itself. And we don't have a center of the circle, so we can't identify it, unfortunately. So BD is congruent to LM. Okay, if that's the case, then we can say the corresponding arcs would also be congruent. So we would say arc BD. We'll say if, then. So if these are congruent, then that means arc BD would be congruent to arc LM. And that's the first thing we really need to know when it comes to the chords and the corresponding arcs. Okay. All right. The next thing we're going to need to know. So with this thing, is this an auto focus? There we go. Okay. So for this one, let's take a look here. You'll notice we have this. Oh, I was looking at the wrong one. You'll notice we have a chord going through the circle, and this is a special kind of chord. This is a diameter. Now, in a circle, if the diameter or radius, okay, so let's say this wasn't here, let's say it was just the radius, that would work as well. So if it's a diameter or the radius, if it is perpendicular to a chord within that triangle, let's try this again. All right, if it is a diameter or radius, and it's perpendicular to a chord within the circle, there we go, look. It's going to do something very important. It's actually going to bisect this chord, which means this would be congruent to that. TU would be congruent to UV because this diameter or radius, if you did CA, is perpendicular to it. It also bisects these two chords. These two arcs rather. So this arc, TV, would be bisected by this line segment, okay, because it's perpendicular to the chord. That's something that's important. We're going to be using that with some examples. Okay, in this example here, we're given some information. We're given a circle, it's center O. We have a radius and we have a chord. You'll also notice that this radius is perpendicular to this chord, as stated here. So circle O is a radius of 13 inches, so this radius is 13. OB is 13 inches. Radius OB is also perpendicular to CD, which is 24 inches long. So this line segment is 24, this is 13. If the measure of arc CD, so CD is here, is 134, find CB. Okay, well here's the thing. We know that this is perpendicular to this chord. Therefore it bisects the chord and it also bisects the arc. So if the whole arc is 134, then CB, which is this piece here, is going to be half of that. So we're simply going to say, all right, well, 134 divided by 2. And that will equal, what, 67, I believe? Yep. Let's see, 67. So 67. And there's no units given here. There's no unit of measurement given to us, so we're just going with 67, I guess. All right. Now this is an interesting question. It's saying to find OX. So we're looking for this piece here. We want to know what that is. Okay, so, all right, well, let's think about this. We know that this radius bisects CD because it's perpendicular to the chord. We know the whole chord. We know CD is, we had it over here, 24 inches long. Okay, so if it bisects 24 inches, that means this would be 12. Ooh, so this is 12. We need to find that. How do we do that? Well, we are going to make a right triangle. Check this out. We're going to connect these 2 points. Okay, we know this angle's vertical to that angle, so this should be a 90-degree angle. And we know this would be the radius because it's the distance from the center to the circle itself. So we know the radius again is 13. Okay, so we have 2 sides of a right triangle. All right, that means we can use the third side. We can find the third side by using the Pythagorean theorem. This is our hypotenuse. So we're going to say a squared plus b squared equals c squared. A or b doesn't really matter. We'll say 12 is our a. So 12 squared, zoom in a little bit so you can see a little better. 12 squared plus b squared equals 13 squared. 12 squared would be 144. We don't know what b squared is. 13 squared, I believe, is 169. Let's just double check that. 13 squared is 169, yeah. I don't know if that's what I said. Now we're going to subtract 144 from both sides. I believe it will be 25. So b squared equals 25. And we're going to square root both sides. And b would be equal to 5, positive 5. So 5 inches, actually. So this right here is 5 inches. So OX is 5 inches. Pretty cool. Okay, so for this example, we have quite a bit going on here. We have a circle, 2 chords, and the beginning of what looks like the radius but cut off there, creating it's perpendicular to these 2 chords. So I'll go ahead and write the information we have here, or read the information we have here. Chords AC and DF, which are these 2 chords, are equidistant from the center, which is actually 10 units. If the radius of circle G is 26 units, find AC and find DE. So what are we trying to find? We're trying to find the length of these 2 chords. We know they're equidistant from the center, as evidenced by here. We know these are perpendicular to it. And we know the radius is 26. So just like the previous example, we're actually going to create a right triangle here. So we're going to start with this one here. We're going to connect these 2 points. Okay, and suddenly we have a right triangle. We know that this is 10. We know the radius is 26. That means this would be 26 units long. Okay. And then we can literally just use Pythagorean theorem to solve this. So this would be our C. This is our hypotenuse. So this would either be our A or our B. So we're at a squared plus a b squared equals c squared. We'll do 10 for the a, and b squared was the unknown, equals 26 squared. 10 squared is 100. B squared is b squared. 26 squared, I don't know off the top of my head. And it's 676 for anybody wondering. And now we're going to get b squared by itself by subtracting 100 from both sides. And we will get b squared equals 576. And let's square root that, see what we get. And let's see what happens here. So we have 576. Oh, no, that's not what we want. Square root of 576. There we go. 24. I did not know that. 24 squared. So we're at b is equal to 24. Okay, so this is 24, but we're not done yet, because remember, if this is 24, we don't know the whole length. However, we know that this is perpendicular to this chord, therefore it bisects this chord, which means this is also 24, which means AC is 48. So AC is going to be 48 units. We don't know what the units is. Now, what the units are, rather. This is going to be the exact same measurement, because it's 10, this would be 26. DF would be the exact same thing. So 48. All right. That's basically it. Yeah, that's the only. I think is that the only example we're gonna do. I'm trying to think if I'm missing one. No, that's the only one we're gonna do. So hopefully that was helpful to you guys. I hope that made some sense. Let me know if you have any questions, and we'll move right along. Oh, Stinky's coming to the video. All right, see you guys later.